Well, I must admit I was hoping to sit there quietly and not do anything at all, but I can't really sit down and have someone misrepresent work I've done with George Box. So I want to say, for just a few moments, try and give the gist of the idea, anyway, of what I did do with George Box in a couple of papers in 1959 and 1963, and correct the wrong impression that you may have gotten earlier. We wrote a couple of papers on response surface models in which we talked about, I'm sorry I'm not prepared for this, I didn't expect to say. What? Yes, you're right. Okay, I've got that one. How about this? First order. Well, I don't want to take a long time with this, but I want to say something. And second order. And these two papers were in 1959 and 1963, I've already said that. And they concern fitting a model of one order when you feared that a model of higher order could actually be a better model, and what to do, how to design an experiment for these orders in the presence of bias of higher order. You can assume any order, but we usually assumed bias of second order if you were fitting first order, and bias of third order if you were fitting second order. And so there were two components of this. There was a mean square error, which consisted of two parts, the variance error and the bias error. And the variance error would be the sort of thing that would be considered if you were working with, say, de-optimality or one of those other optimality criteria. Actually, it was an average version, I won't go into that. And the bias was the bias from the extra terms. Now, it's true that when you look at this sort of situation, unless you know what the bias is, you can't make an exact calculation. But what you can do is this. Under certain assumptions about the bias, you can consider the situation when you have all variance, all V, and the other end is the situation when you have all B, and there are various gradations in between. For example, one in between is when the variance contribution and the bias contribution are exactly of the same size, and then as the variance contribution gets higher, you can consider V equals 2B, V equals 4B, shall we say, just to put some scale in. Coming down here, V equals a half B, V equals a quarter B, etc. And you can ask yourself, what would be a typical experimental situation? A typical experimental situation, we argued, would be perhaps one in which V and B were roughly of the same size. We argued that on the basis that if there really were a lot of bias, you wouldn't be fitting the lower order model, and if there weren't any bias, you would be sure of the model and everything would be the all variance situation. What we found was the following. Here is the basic result, and there's a general theorem about this that says when V and B are roughly of the same order, I'm writing it as though it's exact, but that isn't meant to be exact. When V and B are the same order, the appropriate design is one in which design is slightly bigger than the all B design, and it's not at all like the all V design, except of course if you crush in the region so much that you don't allow the points to expand. And so on that basis we worked out various designs, and it's true we did work out some all bias designs, but they were simply as a starting point to expand for the general case. Now, there are a number of calculations in those papers which show things like this. You see regions, or there are calculations from which you can draw diagrams like this, and in the situation when there is a lot of bias, or all bias, the design tends to crouch inside the region. And as you have all variance, the design goes out. In fact, it goes out to infinity, but if you restrict the region, it goes out to the edges of the region, and if you had a V equals B situation, the design would be at some intermediate point, and these details can be worked out exactly. So it's not true that we suggested that you use the all bias design, except insofar as it was the starting point for more general situations.
Norman, thank you for this. Of course, I didn't say that I didn't even talk about an all-bias design and all this. I just made a general remark that they try to minimize, they try to look at the bias. I was only giving credit to the work of Box and Draper. And so it's good that you clarified it, but I don't think I said anything wrong.